So today we are going to see questions related to enveloping cone. So there are only two questions related to this topic. So let us see them one by one. So the question 1 says that the plane z equals to 0 cuts the enveloping cone of sphere x square plus y square plus z square equals to 11, which has vertex as this in a rectangular hyperbola. So what we are supposed to do is we are supposed to show that the enveloping cone of this sphere, which has this as vertex, when sectioned by this plane z equals to 0, this plane z equals to 0 cuts the enveloping cone in rectangular hyperbola. So to do that, first we are supposed to find the equation of enveloping cone. So the given sphere to us is x square plus y square plus z square equals to 11, and given vertex of cone is 2, 4, 1, and we know, like, we have a direct formula to find equation of enveloping cone, which is basically s into s1 is equals to t square, where t is basically tangent at the tangent passing via the vertex of a cone, and s1 is basically a constant term which we get by satisfying the equation of sphere with the vertex coordinates. So using that, we get our enveloping cone as x square plus y square plus z square minus 11 into 2 square plus 4 square plus 1 square minus 11 is equals to 2x plus 4y plus z minus 11 whole square. So if we simplify it, we'll get x square plus y square plus z square minus 11 into 2 square 4, 4 square 16, 21 minus 11, which is basically 10, is equals to 2x plus 4y plus z minus 11 whole square. So this is basically equation of our enveloping cone. So in the question it further says that this enveloping cone is cut by plane z equals to 0. That is, enveloping cone is cut by plane z equals to 0. So the z, when it is cut by z equals to 0 plane, so it must satisfy the equation of enveloping cone. So using that, I get x square plus y square minus 11 into 10 is equals to 2x plus 4y minus 11 square. So this is the equation of section that we got when the enveloping cone is cut by plane z equals to 0. So in question we are supposed to prove that this is basically equation of a rectangular hyperbola. So to confirm if it is a rectangular hyperbola, we need to show coefficients of x square plus coefficient of y square, that must be equals to 0. So let us check if coefficient of x square plus coefficient of y square is 0 or not. So for that, first let us simplify the equation of section that we got. So that is basically 10x square plus 10y square minus 110 is equals to 4x square plus 16y square plus 121 plus 4 to the 8 to 16xy minus 88y minus 44x. So we can take the equation on left hand side to right hand side, and we'll get minus 6x square plus 6y square plus 16xy minus 88y minus 44x plus 121 plus 110, which is basically 231. It is 231 is equals to 0. So my coefficient of x square is basically minus 6 and coefficient of y square is 6. and their sum, which is minus 6 plus 6, that is 0. So the plane z equals to 0 cuts the enveloping cone in rectangular hyperbola. So this is what we are supposed to prove in this question. So let's move on to next question. So the next question says that show that the enveloping cylinder of this ellipsoid with generators perpendicular to z-axis meet z equals to 0 in parabola form. Okay, so first we are supposed to find the equation of enveloping cylinder, and then we'll cut that with plane z equals to 0, and then we are supposed to show that the section that we got when we cut the enveloping cylinder with plane z equals to 0 is basically a parabola. So if let's say this is my ellipsoid, so this will be basically my cylinder, that will be the enveloping cylinder to this ellipsoid. And so let us assume that, so let's write the information that is given to us first. So ellipsoid is basically ax square plus by square plus cz square minus 1 equals to 0. And in question it further says that the generator is perpendicular to z-axis. So direction cosines of z-axis are basically 0, 0, 1. So let us assume that generator has direction cosines as L, M, N. But in question it is given that generator is perpendicular to z-axis. So using the perpendicularity result, we get 0 into L plus 0 into M plus 1 into N equals to 0. So from here I got my N as 0. So if my generator is passing via any arbitrary point, let's say x1, y1, z1, so equation of generator will be x minus x1 upon L equals to y minus y1 upon M equals to z minus z1 upon 0. So if I equate it with, let's say, some constant r, so I'll get any arbitrary point on the generator line. So any arbitrary point on generator line, so that will be LR plus x1, MR plus y1 and z1. So this is basically my any arbitrary point on the generator line, and for some value of r, this arbitrary point on generator line must be satisfying equation of ellipsoid, because somewhere it will be touching the ellipsoid as well. So for that what I'll do is I'll just substitute this value of this arbitrary point in equation of ellipsoid. So if I do so, I'll get a into LR plus x1 square plus b into MR plus y1 square plus c into z1 square is equals to 1. So if I simplify it, I will get r square into AL square plus bm square plus 2r into ALX1 BMY1 plus AX1 square BY1 square plus CZ1 square minus 1 is equals to 0. So this is my equation. So from here I can find the value of r for which the generator line touch this equation of ellipsoid. So my generator line touches equation of ellipsoid. So if it touches the equation of ellipsoid, so there exists only one route to this quadratic equation that we got in R. So my roots R1, if R1 and R2 are my roots, so my root R1 is equals to root R2. So I got only one unique root, because if I got two roots, then it will not be touching, it will be basically cutting it somewhere like this. So but I'll get enveloping cylinder only when it touches the equation of ellipsoid, not it bisect. I'll not get enveloping cone when it bisect the ellipsoid. So for this quadratic equation to have only one root, my discriminant of this quadratic equation must be 0. So putting b square minus 4ac equals to 0. So if I do so, I'll get my b is 2 into alx1 plus bmy1 square is equals to 4 into my a is al square plus bm square, and my c is ax1 square plus by1 square plus cz1 square minus 1. So this is basically the condition when my equation of generator line will be touching the enveloping cone. So if I simplify it, I'll get alx1 plus bmy1 square minus al square plus bm square into ax1 square plus by1 square plus cz1 square minus 1. So this is the condition. So it further says that, so this is the condition when my generator line is touching enveloping cone. So it further says that it is cut by the plane z equals to 0. So it is cut by plane z equals to 0. So if I put my z1 is equals to 0 herein, I'll get alx1 plus bmy1 square is equals to al square plus bm square ax1 square plus by1 square minus 1. I've substituted z1 is equals to 0. So then I got this relation. So I am supposed to show that this is basically a parabola. So it will be a parabola if h square is equals to ab, where my h is basically coefficient of xy divided by 2 and a is basically coefficient of x and my b is basically coefficient of y. So if I see coefficient of xy in the previous equation, so my h is basically 2albm and my a is coefficient of x square is basically x square and it is y square. So coefficient of x square is a. Let's write it as capital A because small a are involved in our equation as well. So my capital A is a square l square minus a into al square plus bm square. So if I simplify it, I'll get a square l square minus a square l square minus abm square. That is equals to minus abm square. Likewise, my coefficient of y square, that is b, is b square m square minus b into al square plus bm square. So if I simplify it, I'll get b square m square minus abl square minus b square m square, which is basically minus abl square. So from here I'll get 2h as I'll get 2h as 2albm. I forgot to divide by 2 because my coefficient of h is basically, my capital H is basically coefficient of xy divided by 2. So if I open this, I'll get coefficient of x1 y1 as 2al x1 b 2al l and bm. So if I will divide it by 2, I'll be left with al bm only. So my 2h is this. So if I need to check if it satisfies this relation. So h square is a square l square b square m square, and product of ab is basically minus ab m square into minus ab l square, which is basically a square b square l square n square. So clearly my h square is equals to ab. So the section of enveloping cylinder biplane z equals to 0 gives us the parabola, because it is satisfying this relation h square is equals to ab. So these are the only two questions that were asked related to this topic. So thank you for watching.